Hello people, so today we will be solving LeetCode daily question 2050, which is parallel courses 3, and this will be given an integer n, where n indicates that there are n courses labeled from 1 to n, and we'll also be given a 2D integer array relations such that relations j will be equal to previous course means and the next course. Okay, and previous course basically denotes that previous course has to be completed before we can move to the next course. Okay, so and therefore it will be a zero. Furthermore, we'll be given a zero indexed array time, where time I will denote how many months it takes to complete the I plus 1th course. So let's move to the explanation of the test cases. Let's say we are given n equal to 3, which is basically 3 courses, and we'll be given 1 to 3. This basically means that uh, first we need to finish the first course. Okay, let's erase all. Let me copy it again. Okay, let me add it into the next line. Yeah, okay. Yeah, so for completing the course from 1 to 3, I'll be needing 3 months. Okay, or you can consider some other parameter, let's say 3 weeks or something, but in my case I'm considering 3 months, and it is the prerequisite is that first I need to finish the course 1, then only I can move to course 3. Okay, and the second will be I need to finish the course 2, which is basically this. I'm giving the time 2 months. Okay, so that means I can finish the course 2 in 2 months. Then for the course 3 I have given 5. Okay, this means that course 3 will take 5 months, and so we need to return the minimum number of months which we need to finish both the courses, and it is given that we can pick up any number of courses. Any number of courses can be, okay, let me zoom in. Yeah, that any number of courses can be taken at the same time. Okay, so this is okay, so if I try to solve, let's say I can pick 1 and 2 together in 3 months, both 1 and 2 will be finished, and it will take maximum of 1 and 2, that is 3 months will be taken for courses 1 and 2, plus the time taken for completing course 3, that is 5 months. Okay, so in total I'll be needing 8 months. Okay, it is given. Yeah, output is 8. The earliest time we can start the course 3 is at month 3. Okay, so the total time will be 8 months. Now let's move to the second test case. For this we are given that course 1 will need 1 month, 2 2 months, 3 3 months, 4 4 months, and 5 5 months. Okay, and the mapping is done as first we need to finish course 1 to move to course 5. Okay, this, then we need to do course 2 to reach course 5, this path. Okay, this path. Then it is given that we need to do course 3 before, then only we can move to course 5, this. Then it is also given that I need to first finish third course to reach the fourth course, this. Then it is given I can reach fourth, I need to finish first fourth course, then only I can reach the fifth course. Okay, this. So what we can infer from this question is that firstly I'll be needing to reach the fifth course. Okay, because we need to finish all the courses, so at the end we'll be at least having 5 in the answer, like we'll be adding 5 into the answer. Then what we can do for finishing for reaching fifth course, first we need to finish fourth course. Okay, so that means we'll be having 4 also. Okay, and it is not like we need to finish any other course before finishing course 4. And also if we see that we can start 1 2 and 3 courses in parallel time. Okay, because in the span of 3 months we'll be over with course 1 and course 2. Okay, so let's add 3 also, because in 3 months all the 3 courses will be finished. Then in the next 4 months fourth course will be finished, and in the last 5 months fifth course will be finished. So this sums up to 12. Okay, so this is how we can see that the output is 12, and this is how we'll be approaching the question. So this basically is a question of topological sort. Okay, so let's move to the pseudocode for this. Firstly, okay, let's create a map to map the edges and nodes and everything. Okay, let's have a map. Let's call it graph. Okay, because it and we can consider that every node as a graph because it is, and this one is a directed graph. Okay, so then I'll simply be adding graph dot add dot put, basically dot put, using a for loop for I equal to 0 to I less than n. Okay, graph dot put I comma, let's have a map of integer int and list of integers, because one course can be mapped to some other like more than one course also. Like in the previous example we see that 3 is mapped to 5 also and 3 is mapped to 4 also. Okay, so we can use a list of integers to store all the courses which we need to do before starting with that, which we can, to which course we can go after starting that particular course. Let's have list of integer. Okay, and and I'll be adding graph.put empty list. Okay, empty list. Then after this for loop, let's calculate the in degree for each graph. Let's have an array of in degree of size n. Okay, and we'll be checking in degree for every edge of the graph. Okay, then for edge in relations. Okay, we'll be given the relations array. Then what we'll be doing, we'll be having x equal to edge at 0 -1. We'll be doing -1 to make it 1 based indexing, and similarly y will be equal to edge 0 -1 to make it 1 based indexing. Then in the graph we'll be adding graph.put a graph.get x, and in the answer we'll be in this list we'll be adding dot add y. Okay, and by now we have finished the formation of the graph, and okay, sorry, and we'll be also updating the in degree for that particular edge. Okay, so this is how we have formed the graph. So now we need to find how many hours we need. Okay, so till here we have just formed the graph. Okay, so let's sorry, yeah, so now let's start with let's declare a queue, and it will be containing all the nodes for the edges. Okay, queue of integer, let's call it nodes. Okay, and then we need to find the maximum time we need to complete all the courses starting from that particular course. Okay, so let's declare an array of max time which will be of size n. Okay, then for loop, okay, let's name it nodes because we can. Then okay, then for and for, okay, sorry, for no nodes and equal to 0 to nodes less than n. Okay, and then we'll be checking that if in degree of that particular node is 0, that means that we this is one of the starting index. Okay, so then what we'll be doing, we'll be adding that to the nodes from where we need to start. Okay, ln node equal to 0, node less than n. Okay, we'll be adding nodes dot add node, because that will be one possible solution from where we can start. Okay, then and max time for that particular node, as it is the starting node. Let's say this, as we can see, the in degree for 1 is 0, similarly in degree for 2 is 0, in degree for 3 is 0. Okay, so this means that we can the course 1 will take its own time, which is 1 month. Course 2 will take 2 months. Course 3 will take 3 months. But let's say in degree for 4 is 1. Okay, this means that there is some particular course which we need to complete before starting this course. Okay, so here the max time taken by that particular course will be equal to the given in the time array. Okay, time node. Then we'll be start traversing in the queue while not nodes dot is empty. Okay, we'll be starting that. Let's say node will be equal to nodes dot remove. Okay, first we'll be removing the top node, and then what we'll be doing, we'll be traversing all the mapped courses through that node. Okay, so for let's call it connected connected. Okay, let's call it simply I. Okay, I in graph dot get node, and we'll be traversing in that into all the courses through which it is mapped. So the maximum time for that I will be equal to maximum of current max time of I, and max time of that particular node plus time I. Okay, so what this will basically do, that we'll check that if the maximum time is already present, then it will do nothing. But if we let's say in this example we can go from course 1 to course 5. Okay, so the maximum time here is 1 month, and the maximum time the time here is 1 month, and here it is 5 months. Okay, so we'll be picking up 5 months, because in 5 months we'll be able to finish first course as well as fifth course. Okay, if the rest of the nodes were not given, this would have been the scenario. Okay, uh, yeah, so here, and then we'll do in degree of I minus 1. Okay, and then we'll be checking that if in degree of I reaches 0, okay, then we'll it means that this is also node from where we can start. So we'll be adding it to the nodes dot add I. Okay, and after this we'll be having we'll be done with most of the things, and after this the maximum answer will be stored at the node which will be taking the maximum time. Okay, after doing all these calculations, so what we'll be doing, we'll be running a for loop node equal to 0 to node less than n, and let's keep a track of answer. Let's set it minimum value, min underscore val. Okay, because for getting the maximum value we need to do the give it the answer to minimum value. Okay, then what we'll be doing, we'll be just updating answer equal to maximum of answer and max time in that particular node. Okay, so and after this we'll be just simply returning answer. Okay, so this is how we'll be doing. So now let's move to the coding window, and let me zoom in a little bit or more. Yeah, so let's start with first declaring the map of I comma list of uh, integer. Let's call it graph, which will be a new hash map. Okay, then we'll be doing for and I equal to 0, I less than n, I plus plus graph dot put I comma new array list. Then after this for loop, we'll be declaring a int degree array, int degree, which will be of size n, new int n, and then we'll be adding the values to the map for int edge in relations. Okay, let's call it x would be equal to edge 0 minus 1 to make it 1 based indexing, and similarly int y will be equal to edge 1 minus 1. Okay, then we'll be doing graph dot get x dot add y. Okay, and then we'll be just doing int degree of y, incrementing it by 1. Then what we'll be doing, we'll be having a queue integer, let's call it nodes, which will be the new linked list. Okay, then let's have an array for maximum time, and max time, new int of size n. Then we'll be start traversing in the queue while not nodes dot is empty. Okay, then what we'll be doing, let's have int node equal to nodes dot remove. Okay, so I guess I missed one step where I need to add the nodes into the queue. Yeah, okay, for int node equal to 0, node less than n, node plus plus, and we'll be traversing in the int degree array at if int degree of that particular node is 0. Then what we'll be doing, we'll be adding it to the nodes dot add node, and then what we'll be doing, we'll be just max time of that particular node will be equal to if okay int degree of node max time of node will be equal to time taken that by that particular node originally. Okay, so after this for loop, we'll be traversing in the queue. Node will be equal to queue dot remove, and then for simply in graph dot get node, this will be returning with the array list. Okay, then what we'll be doing, max time for that particular I will be equal to math dot max time at that particular I, or max time at that particular node, max time at that particular node plus time of I. Okay, and then what we'll be doing, we'll be uh, decrementing the in degree of I. Then we'll be checking that if in degree of I becomes 0, we'll be adding it to the nodes queue. Okay, nodes dot add I. Okay, so basically we are checking all the neighbors, and after this our maximum time array will be updated with the maximum time taken by the all courses to complete them. So let's create a variable result equal to 0. Okay, not equal to 0, it should be equal to integer dot min underscore value. Okay, then for, let's say, int I in max time array. Okay, so what we'll be doing, result will be equal to maximum of result and I. Okay, so after that we'll be just simply returning result. Okay, so this should work. Compiler error. Oh, so I plus equal to at the line 4. Okay, I plus plus. Cannot. Oh, map. Oh, sorry. Integer. Integer. Okay. Graph. Okay, it should be graph. There are so many typing errors. I just wish there should be no errors in the logic. Yeah, and it works fine. So let's submit it. And it gets accepted. So this was it for today. Thank you for watching.